All right, so we're going to actually apply this sum and difference of cubes formula here. All right, so the top one is our sum of cubes formula because it's a plus sign in the middle, and the bottom one's a difference of cubes formula. We are asked, please, please, pretty please, factor x cubed minus 27. All right, so the reason that we're able to use the difference of cubes here, well, it's got a minus sign there, and both of these terms can be expressed as something to the third power. All right, obviously x cubed is equal to x to the third power, but you can also express 27 as a number to the third power. All right, 27 is a perfect cube is what we would say. So the first thing I'll do is I'm just going to write it so that it's as something to the third power. So this is x cubed minus, and I'm going to write it as 3 to the third power. All right, 3 to the third power gives me 27. That's the idea. All right, from here, the rest of it is just applying this formula. So this is going to be my A term, and this is going to be my B term throughout. All right, so it starts with A minus B in parentheses. So that's going to be x minus 3. All right, I'm just kind of like here, it started with the third power. Here they lose the powers. That's what I'm doing here, is I'm just losing the exponents. And that's my linear factor. So the term here is an a squared, which is going to be x squared. Then it's a plus sign. That's an important part here. Make sure you get the plus and minus signs correct. All right, plus, it says a times b. So that's going to be 3 times x, and that'll just be 3x, plus, and then it says b squared. So you could write, you could say b squared, 3 to the second power, but we're going to go ahead and square that out. So 3 squared is 3 times 3, so 9. All right, and there it is. This is now in factored form. That's what we did. We just factored it. Now, I want to mention here, you do not have to try to factor this expression again. As far as I can dream up that I know of, this thing never factors. All right, so don't have to go through any extra steps trying to break this down further. All right, let's go ahead and do another one here. So we're going to factor 2x to the 6th minus 250. So as it is right now, 2 is not a perfect cube. 250 is not a perfect cube either. But what we need to do first is check for that greatest common factor. We gotta divide by 2. We gotta factor out of 2. So when you're factoring, you actually keep the number out there. So I'm just going to say 2, and then it's going to become an x to the 6th minus 125. Okay. All right, and this is going to be the expression that I have to apply the difference of cubes on. First thing I want to do is I want to write it so that each of these terms are expressed as a perfect cube. Well, x to the 6th, that's the same as x to the 2nd, and then all of that raised to the 3rd power. So it's like x squared times x squared times x squared gives you x to the 6th. Or if you have a power to a power, it gives you multiplication of them. And then 125, that one you might not know, but this is a perfect cube. All right, what you can do is take the cubed root of 125 if you're not sure. The way we do that is math, and then there's your cube root button. 125, it's 5. So what that means is 5 times 5 times 5 gives you 125. We wanted to find something so that when it multiplies by itself 3 times, we get this value. So this is equal to 5 to the 3rd power. Don't know why I wrote that one in red, but I did. All right, so my A term is going to be like an x squared. My b term will be a 5. Let's go. We'll go ahead and factor this thing. So 2. And it's going to start off with a minus b. So that's going to be x squared minus 5. Squared minus 5. And then it goes a to the second power. So this is going to be x squared to the second power. X squared times x squared. That's going to be x to the fourth power. And then a times b plus. That's going to be a 5 and then an x squared. And then b squared is going to be 25. So for 5 times 5. And that's it right there. It's all factored nice and neat for us. Great.